Okay, so today let's go straight into the topic. So there are some questions here as usual that you can watch the videos. This is just a reminder of division algorithm. Those questions like this is very, very, very common. Okay, so you'll have square root of p where p is prime is irrational. Square root of mn is irrational where m and n are, I think, relatively prime. Or you can have specific questions. Square root of 7 is irrational. Square root of 11 is irrational. Square root of 22 is irrational. How do you prove it? So that's one kind of question. The second type you can have is log PQ. Show that log PQ is irrational. Log 2, 3 is irrational. So many questions of this type has been asked from this chapter. Obviously, look here, I'm not going to do the solution, but general approach is that it's a proof by contradiction. So let's take square root of 11, for example. You will assume it is rational. So square root of 11 is a by b, where a and b are integers, b not equal to 0, GCD of a and b equals 1. So then you get 11 equals a by b whole square. 11b square equals a square. And then you take this equation, again, watch this video. You play around with that equation with divisibility rules, and you will get a contradiction, which means the number had to be irrational. So do lots of practice with this. Don't get bogged up by, oh, this exactly square root of 2 and I know how to do. I don't know how to do square root of p. I want you to see the big picture concept, because they can change the question slightly, but the concept is the same. You assume it's rational, write a by b, get the formula you need, and use the divisibility techniques to show its contradiction. Okay, so there is a solved question there. The extra practice has 2 of those, so definitely do practice on that. So that's one thing. The main focus of today is going to be GCD. So let's talk about GCD. Okay. GCD is greatest common divisor. So it's literally a very simple definition. If you can understand the English expansion, greatest common divisor, that's your definition right there. So the definition is, if GCD of A and B is equal to D, it is a common divisor, which means divisor means common factors. Okay, so it divides both A and B. So first thing. The second thing is that it's the greatest common divisor. What that means, if there is another number that divides these two, then that number has to be smaller than or equal to D. Okay, so 1, it's a common divisor. 2, if there's another common divisor, it's smaller than this number or equal to this number. So let's see an example. So for example, if I had 24, let's say I have 12 and 18. So the first you do the common divisor. That's the first thing. So for that, you first need to find the divisors. So let's start there. Divisors are the factors, the numbers that divide this number. So 1, 2, 4, 6, 12. 12 1s are 12, 6 2s are 12, 4 3s are 12. Okay. 1, 2, 3, 6, 9, 18. 18 times 1, 9 times 2, 6 times 3. Okay. So that's the divisors. Then you have to find the common divisors. So you find, so next is the common divisor, which is 1, 2, 3, 6. And then finally, you have greatest, sorry. You have greatest common divisor. So you find the biggest one. So that's 6. So that's GCD. Any doubts in the question concept? So not question concept, in the definition and the concept. While I try to draw a rectangle, I'll wait to see if you have any questions. I don't see any questions. Okay, so then there's multiple ways to find GCD, okay? all 4 questions here use different methods. I'm not going to do them here. You have to click here to see solution. Let's just do this one here, which is the brute force thing that we just did. 1, 2, 3, 4, 6, 8, 12, 24. And this is a prime number. What's the GCD for this? 1. Excellent. So GCD is just 1 here. Now, question for you guys. So, knowing everything you know now, what's the smallest GCD I can get? 1. Excellent. So, GCD is always bigger than or equal to 1. Okay. So, you can never have a negative GCD. You can never have 0 as a GCD. Every number has 1 as a factor. So at least 1 is a common divisor. So you can never have a GCD other than 1, smaller than 1. Okay. Another thing, definition is if we have 2 numbers, A and B, which has the GCD 1, for example, here we had that, then A and B are called relatively prime. So they're like prime relative to each other. So for example, the numbers 9 and 10, they're not prime numbers, but they have nothing in common. No factors in common except 1. So those numbers are relatively prime. So these are all the definitions you need. If there's any doubt in that, just let me know. If there's not, we are going to go to the question. I don't see any doubts. Can we go to the question? Yeah, I don't see anyone asking any doubts. So let's just go to the question. Excellent. So the question here is to find x and y such that 432x plus 1056y equals GCD of those 2 numbers. So this is Besut's identity. Besut's identity tells you there is an x and y where this is possible. So if you have a and b, you can find an xy such that ax plus by equals GCD of those 2 numbers. So in your course notes, Euclidean algorithm is given, Besut's identity is given. Why those make sense, what's the logic, the proof behind this is given. We won't do that in tutorial, but you need to know that, okay? Just go through that, ensure that it makes sense to you. If it doesn't, ask an officer. Today, we are just going to use that to find out. So now one thing is there might be many x's and y's which fulfill this equation. You're not going to sit there in a quiz and trial, okay, let x be 1, y be 2, and let's go one by one and see which one works. That's obviously not possible, so you're not going to do that. Instead, we need a systematic way to find this x and y no matter how big those numbers are. So for that, we'll use Euclidean algorithm. It will make sense once I show you how to do it, okay? So Euclidean algorithm is something you definitely should know. It's not at all difficult, but it's just computation, very like mindless computation that's easy marks to get if it shows up in your exam. So definitely know how to do it. It's just using division algorithm on these 2 numbers. So that's the first step. So this is your division algorithm. This is your A and B terms. So find the coefficient and the remainder. So what's the quotient and the remainder when you have the 1056 and 432? Find out and let me know. Oh, wow, you guys are quick, eh? And what's the quotient? How do you get the remainder before the quotient? Okay. Now, in Euclidean algorithm questions, the key is to know what to bring down. This is all you need. This is the only complicated thing. Your smaller term in the division algorithm becomes the bigger term in the second line, and the remainder becomes the smaller term. Like this is what you do. Every time you keep, this is why I have the bracket and the squares. The brackets keep going down and the squares keep coming down. So this is the only thing you need to not get confused in Euclidean algorithm. As long as you don't get confused with this, you'll be fine. And then you keep doing the division algorithm. So tell me the quotient and the remainder. Excellent. 2 and 48. Same thing. The smaller term now becomes the bigger term, so this bracket, and the remainder now becomes the smallest term and comes into the bracket. So what's the quotient? What's the remainder? Awesome. 4 and 0. Now, once you hit the remainder, 0 stop. Okay, once you hit the remainder 0, the remainder above that is your GCD. Again, why is this make sense? Why is this the GCD? How does Euclidean algorithm work? Look in your course notes. It's all given why it makes sense. Okay, that's your GCD. The last non-zero remainder is your GCD. Any doubts so far? We haven't found what the question is asking, but we need this to find that. Any doubts so far? If there's no doubt, just say it makes sense or something like that, so I can keep going. Excellent. So now I need to rewrite. So my goal now, so I want to find x comma y such that 432x plus 1056y equals 48. So I want to rewrite 48 in terms of 1056 and 432. So you are basically going to go back in Euclidean algorithm. I'll show you what you mean. So you start with this line from where you got 48. So from here we know 48 is 432 minus 2 times 192. Okay, so it's literally start at the line where you got 48 from and rewrite what 48 is. So now if you notice again, I want 1056 and 432. That's the numbers I want. I don't want 192 and all that. So I need to get rid of 192 here. 432 is here. I don't get rid of that. So you're just going back. You rewrote 48. Now you're going to rewrite 192. So if you had more steps, you're going to keep rewriting the remainders. Okay, so the remainder is always going to get replaced. So you keep going backwards in the steps. So now it's going to be 432 minus 2 times. Instead of 192, you have 1056 minus 2 times 432. This is again from this line here. So keep replacing. So here we are done in 2 steps. If you had more steps, it's going to literally be just replacing the remainders. Okay. Now bring all the 432s together. So it's going to be 432 and minus 2 and minus 2, which is 4. So 4 plus 1 is 5. So 432 times 5 plus 1056 times minus 2. So I'm just rewriting the terms, rearranging them. And if you actually calculate this, you will find this actually is 48. Which means my x is 5 and my y is minus 2. So again, you first find the GCD using Euclidean algorithm, and then you rewrite it. Rewrite the remainders using the lines from the Euclidean algorithm and keep going until you hit the first line, and then you'll have your x and y values. Again, this is nothing conceptually too complicated. It's just making sure you're rewriting the right things and all that, which comes, you do like 2 questions and you'll be fine. Where did the 5 come from? Sure. Let's expand this. So this term right here is 432 plus minus 2 times 1056 plus opening the brackets here. Minus 2 times minus 2 is 4. 4 times 432. And so this 432 and this 4 times 432 becomes 5 times 432. Does that make sense? So this minus 2 and this minus 2 becomes 4 when you multiply. And does that make sense for you? Okay, awesome. Any other doubts? If you have any other doubts, just let me know. Okay, no doubts, no doubts. Okay. If not, let's try the next question. So I'm gonna give you guys a minute to think about it and then we'll take it up. When you say long division, is it to find the quotient and remainder? Then yes. I mean, you don't need, hopefully you don't, it's not too difficult to do, right? Like, are you expected to know how to find the quotient and remainder used for the division algorithm stuff? Yes. Any ideas for this, guys? Okay, so let's start with something simple. I am going to ask you guys. So I know the x is equal to GCD of 49 and 7x plus 4. So by definition of GCD, again, I'm going to show you the definition here. What does this tell me about x? Look at the definition given up. Look at this definition. What does this tell me about x? Awesome. It tells you x divides 49 and x, because if it's a greatest common divisor, it's a common divisor. So it divides both of them. Now, if x divides 49, what does that tell you? What can you tell me about x? It is less than or equal to 49 for sure. You can go even stronger. You can make a more stronger claim. Yeah, it's either 1, 7, or 49, because that's the only numbers that divide 49. So now you can see how we went from a very vague question to literally only have 3 cases. Case 1, x equals 1. Case 2, if x equals 7. And case 3, if x equals 49. You literally only have 3 cases. So just knowing the definition is what led you to these cases, okay? And now you just, as I told you in this chapter, cases and like plugging in numbers for those cases and literally trying brute force is very common. So if x equals 1, GCD of 49 and 7x plus 4 is just GCD of 49, comma 7 plus 4 is 11, which is, what's the GCD of 49 and 11? 1. Yeah, they have nothing in common, okay? Which is x. Now if x equals 7, GCD of 49 comma 7x plus 4 becomes GCD of 49 comma 7 times 7 plus 4. I don't even need to compute this. I can find the GCD. Does anyone know what the GCD of these two numbers are? Without even finding out what the second number is, I can tell you the GCD. Yeah, it is 1. Now, how did I know that? Like one way is you can find it. It's 49 and 53 and the GCD is 1. Another way, does anyone else know how else I can find it's 1 very easily? It's okay if you don't. Okay. So the second number is literally 49 plus 4. Okay. 49's multiples are 1, 7, 49. And you have a number 49 plus 4. So your 4 is the remainder here. There is no way you're taking 49, adding 4 to it, and getting a number that has 7 or 49 as a factor. Because the only factors of 49 are 1, 7, 49. So the second number, if the GCD is something other than 1, it can only be 7 or 49, right? Because that's only factors. So you can't have 49 plus 4 being a multiple of 7 or 49. So obviously that has nothing in common. So that's one way to think about it. So put that to use here. Use this logic here and tell me what the GCD is here. So this is GCD of 49 comma 7 times 49 plus 4. What's the GCD? Yeah, it's 1. Again, same logic. 7 times 49 plus 4. It's a multiple of 7 plus 4. A multiple of 7 plus 4 cannot be a multiple of 7 or 49. Okay, so 49 and that number can have nothing in common. So this is not equal to x, these two. So here x equals 7, here x equals 49. So in both these cases, the GCD is not equals x. So those cases are not correct. So the only x where x equals GCD of 49 plus 7x is equal to what x? No, is when x equals 1. That's the only answer. Any doubts? Does this make sense? Okay, so there's another question like this. Watch so that you can get more practice. And then there's another question like this, which is slightly different because you don't have a constant anymore. If you notice, they both are terms that have x in it. But that's just one extra step you will do. Once you do that step, it's going to be pretty similar to what we just did. Okay. Any doubts, or can we do the last question for today? So we might end a bit earlier. If you have any questions, let me know. If not, try this. It's a bit of a longer question. Um, I don't want you to generalize like that. In questions like these, yes, if you use the definitions of GCD, you'll have to do some simplification so that GCD can be like it. I wouldn't say apparent, but it's like more you'll simplify the question to a more workable question in most questions, not all of them. A lot of questions do, especially these kind of questions that we just did, you'll use the definition of GCD, like do some small tricks like we just did for the number with 49 to get specific cases or specific conditions on the X or the GCD we are finding. How you do that will vary from question to question. But again, GCD has only two things, the definition. So like there isn't much like variety you can play around with. Okay, so this is an if and only if question. You're doing both ways. Okay, so let's do both separately. Proof if GCD of A comma B equals D, then I'm just going to preface by saying there might be shorter ways to do this particular question. There might be a shorter way to do it than the one I'm doing. The one I'm doing, I'm aiming to be mathematically correct, rigorous, and not skip any logical steps. So it might be slightly longer, but I'm just trying to cover as many concepts as I can, help you see how to do proofs as well as I can show you, and also making sure we are mathematically complete the proof. Okay, what proof method do you want to use? There's two you can potentially use with no issues, but one of them is nicer to use here. Which proof method? What are the proof methods for if-then statements? Do people remember? Okay, I'm gonna go with contradiction. Okay, you could attempt contrapositive. I'm pretty sure it's doable, but contradiction is more straightforward, so I'm gonna go with that. Okay. So you assume the if part and the opposite of the then part. So assume GCD of A comma B equals D and GCD of A by D comma B by D equals C, which is greater than 1. Okay, where A and B is non-zero, and if they are integers, and C and D are natural numbers. Now, last tutorial, some people had a question about this. I just want to make a comment here. Technically, the opposite of that is that the GCD is not equal to 1. Okay, i.e. C is not equal to 1. That's technically the opposite. But remember, we said GCD is by definition greater than or equal to 1. It can never be less than 1. We just talked about that earlier. So if I say the GCD is not 1, it means it has to be greater than 1, because less than 1 can never happen anyway. So the second I know it's not equal to 1, I can say it's greater than 1. Hopefully that makes sense where I got C greater than 1. Okay. Any doubts in the assumption? I don't see any. Tell me what this tells you. If I know GCD of A and B is equal to D, what does that tell you? Similarly, if I know GCD of A by D and B by D is C, what does that tell you? What's the definition? If D is the GCD of A and B, what does that tell you about D? Think back to the definition of GCD. Read the board and just type it in the chat. Yeah, D divides A and D divides B, okay? Also, similarly from the other one, it has C divides A by D and C divides B by D, okay? Now, remember what this symbol means. So this symbol here, what that means, example. Everything in green is explanation, by the way. 3 divides 6. This means 6 equals 3 times 2. 12 divides 48. This means 48 is 12 times 4. So in general, if you have x divides y, this means y equals x times an integer. That's the symbol's meaning. Don't forget that aside. I'm going to use that here, okay? So this means A is D times K and B is D times L. And on the other side, we have A by D equals C times M. B by D is C times N for some K in the integers, for some L in the integers, for some M in the integers. Again, if you guys have any doubts, just put it in the chat. For some N in the integers. Okay. Now we're going to pause this left side and we're really going to focus on this half of it. Again, if you have any doubts, put it in the chat. So simplifying, this tells me A by D equals CM and B by D equals CN. So that's A equals CMD and B equals CND. If you notice, this tells me A equals CD times M and B equals CD times N. So this basically is telling you CD divides A and CD divides B. But by definition of GCD, again, I'm going to take you back to the definition of GCD. Look at the second line. If you have a common divisor, if there is a number that divides A and B, then that number should be less than or equal to the GCD, which makes sense. If you have another common divisor, it has to be less than or equal to the GCD, okay? So you're going to use that fact here. So if you, here you have a common divisor, that has to be less than or equal to the GCD. Now, since D is a natural number, you can divide both sides by D. This tells you, so cancel out D, C is less than or equal to 1. Hopefully you see where the contradiction is, and this is why it is very important. I talked about C greater than 1. So this is a contradiction. Now, I want you guys to take a second and think about the question. Now that we did one side of the proof, that makes sense, right? If GCD of A and B is D, like you have D is the biggest common factor of A and B. Now, if you divide D, A and B by D, obviously they shouldn't have any common factors left because D is the biggest common factor. So when you divide it by that, the stuff that's left have nothing in common. So that's why the GCD becomes 1. So here what we just showed is that D is the biggest common factor. If you divide by D and you still end up having something in common, that can never happen. Because if you have something in common after you divide it by D, then D is not the biggest common factor. So that's where you get the contradiction. Any doubts in this side of the proof? Yeah, you can say, you can, the problem with if you said C not equal to 1 in your thing is now we had C less than or equal to 1, right? So C, you could say, okay, then why, you'll have to write again say, okay, our assumption was C not equal to 1. We now got C less than or equal to 1, but C can't be less than 1 because GCD is always greater than 1. You just have to explain that at the end. Any other questions? Okay, we are not done. Don't forget, we are only done one side of the proof. So The second side, if GCD of A over B, not A over B, A over D and B over D equals 1, then GCD of A comma B equals D. We are going to do a direct proof for this. Direct proof is way easier. Okay, so for your direct proof, don't forget, what's your assumption? You assume the if part, and then you show the then part is true. So assume GCD of A by D and B by D equals 1, where A and B are integers, A and B are not 0, D is a natural number. Okay. So same thing that we did earlier. This means, something I'm going to do just for simplification is I'm going to rewrite, call this X and call this Y, just to make our life easier so we can find what A and B is. You don't have to do that. I'm just going to do that. So let A by D be X, B by D be Y. This means A equals dx and B equals dy. Okay. So now if you want to find GCD of A and B, then you're finding GCD of dx and dy. Now, obviously my claim is that GCD has to be D. So I need to make sure it satisfies both the conditions. So I need to make sure first that D divides A and D divides B. I also need to make sure that if C divides A and C divides B, then C is less than or equal to D. You need to ensure both of these conditions are met. If both of these conditions are met, then D is the GCD, okay? The first one is way easier to show. So I'm just going to rewrite here. So since D divides dx, obviously, and D divides dy, where x and y are integers, don't forget that. We're working with integers here. Because A and B have D in common, like D is a factor for A and B, so they are all integers here. This means D divides A and D divides B. That's it, you're done. First part is pretty much straight from there. The second part needs a bit more work. So how do you show if C divides A and C divides B, C is less than or equal to D? So if you guys are watching my recording and you were in my previous tutorial, we just wrote it in words for the previous tutorial. I think that's a bit tricky because for 102, we do expect you guys to be rigorous. Like upper year courses, writing it in words would probably suffice, but in 102, we do want you to be rigorous. Even in upper years, how you write is important. But anyways, this is a fundamental concept trying to prove. So let's just be rigorous. So how will I do this? So I'm going to borrow Besut's identity here. So by Besut's identity, also I'm probably butchering this person's name. I apologize to that person. There exists x and y such that ax plus by is equal to the GCD of A and B. Okay, that's Besut's identity. So if you look at this right here, so there exists m and n in integers such that, so this is integers, A by B times m, not B, D, B by D times n equals 1. Here x, y, a, b and all are generic, not specific to the question. This is a general identity form, okay? Not what we are, not the question we're doing here. Not the x and y we are doing here. Don't get confused. This is just general statement. So I'm applying that here, which is if you take this one and highlight it, we know the GCD is 1. So there should be an integer m and n such that a by a over d times m plus b over d times n equals 1. Now this, if I simplify, this is am plus bn by d equals 1. So this is just am plus bn equals d. Now, why is this helpful? I'll show you why. Because now let's come back to what we are trying to prove. Okay, we are trying to prove if C divides A and C divides B, then C less than or equal to D. So this is a proof within a proof, which is a direct proof here. So assume there is a C in the naturals such that C divides A and C divides B. Okay, because C divides A, C divides AM. And because C divides B, C divides BN. Hopefully that makes sense. If C divides A, then C divides AM. Simple identity for divisibility stuff. Now, if C divides AM and C divides BN, then C divides AM plus BN. Which means C divides D. Which means C is less than or equal to D. Any doubt in that? I know the second one is a bit, can get a bit tricky. So does this make sense? So again, you use Bezout's identity on the AN, this thing here, which is A over D and B over D equals 1. And then you take D as a common factor and write AM plus BN equals D. Now, if C divides A and C divides B, C divides AM and C divides BN. So C divides their sum, which is D. So C divides D. If C divides D, then C has to be less than or equal to D. So now you have number 1 saying D is a common divisor, and number 2 saying if there's another common divisor, it's less than or equal to D. So combining 1 and 2 is the definition of GCD. So D is the GCD of A and B. Does this make sense? Any doubts?